potential energy only depends on the position. You can store potential energy, but for kinetic energy, you need to keep things moving, and you don't want the crop to be shaking when you move them around. So it's good that the leaf can store the energy from the sunlight in a form of internal potential energy. So when you eat your crops, those internal energy of the crop becomes your energy. The internal energy of the crop decreases as you digest your agricultural product and turns into your kinetic energy. Maybe you are running, so your kinetic energy increases. Or maybe you become fat, that is internal energy of your body. So the agricultural activity is basically a giant process of turning the energy of the sunlight into a form that we can use. It's complicated, but you know how to deal with the system, so you know how to deal with this. That's it. Yeah. Okay. Since we still have time, let's use the thing you prepared. Even though we're not going to test any, I'm not going to give you an exam on this because I don't have time to get through it. This is a demonstration of energy conservation in fluid, aka Bernoulli's principle. So what you're seeing is a tube with a thinner part here and wider part here. When this part is thinner, the air passing through it must speed up because the tube is thinner. If you want to pass the same amount of air through this tube, then they must speed up at a thinner region. Now, a water has energy. So if it increases its speed, which means the kinetic energy increase, some other energy must decrease because energy is conserved. The way it gets this extra kinetic energy is because it turns some other form of energy into kinetic energy. That other form of energy is pressure. To be more precise, it's pressure times volume because pressure is not having the same dimension of energy, but you will see pressure is actually energy per volume. So the way the water speeds up is because it turns the pressure into kinetic energy. Pressure corresponds to the internal energy of the water. So that's why even though the height is not changing, you can have a pressure difference. So if the pressure here is lower, you will see the water being sucked up. You can see that at here, the kinetic energy of the air is bigger. So the internal energy is smaller, which is pressure. At here, the internal energy turns into the kinetic energy of the water. So the pressure decreases and you suck the water out. Okay? That's not going to be our exam, so just tell him we have used this device, it's not wasting his time. Alright, so that's all I want to mention for energy conservation. I will modify the homework because I do not have time to cover all of them, which means your homework will be shorter. That's the good news. And yeah, so the lecture is officially over. I'll stick around if you have questions. And that's it. No office hour in the morning, I have a meeting, but I'll be there in the afternoon.